The question says, given that triangle ABC is similar to triangle PQR and ABC and PQR are right angle triangles, right? So very important. The first point given here is that these two are similar triangles, right? Now there are many properties associated with similar triangles, right? Many important theorems that we know. So you all have to recollect those quickly and try to use the right one here. Then moreover, he says these two are right angle triangles, right? ABC and PQR are right angle triangles where the ratio of their areas is 49 by 441 and PR is 5 centimeter. One of the sides is 5 centimeter. If AC is the hypotenuse of the other triangle, then what is the radius of the circumcenter of the triangle ABC? Let us consider these two triangles. See, two right angle triangles. So let's say this is the first one. A, B, C. And let's say this is the second one. Right? Remember, these are not two congruent triangles. These are similar triangles. They look alike, but they're not exactly the same. So if you superimpose one triangle on the other, they will not coincide. They'll only look similar. So these are the two similar triangles. ABC is similar to PQR, right? Now we know that the ratio of their areas is 49 by 441. PR is 5 centimeters. This is given as 5 centimeters. And AC is the hypotenuse of the other triangle. He's asking us to find out the radius of circumcenter of the triangle ABC. Now from the properties related to similarity, you know that the ratio of the sides or the square of the ratio of the sides is equal to ratio of areas, right? So we can say AC square by PR square. So you have to take corresponding sides. There are 3 pairs of corresponding sides, right? So ratio of each of those pairs squared will be equal to ratio of the areas. So I can say AB squared by PQ squared equals to BC squared by QR squared equals to AC squared by PR squared. This should be equal to the ratio of their areas. Now ratio of the areas is given as 49 by 441, but keep in mind this is ratio of PQR by ABC. But we have taken ABC in the numerators there, right? So we have to reverse it. This becomes 441 by 49. Be careful, right? Here the inverse ratio is given to us. The reverse ratio is given to us. PQR by ABC. We are taking ABC by PQR. 441 by 49. Now all we need to know here is what is the radius of circumcenter of the triangle ABC. You know that for a right angle triangle, the circumcenter is the midpoint of hypotenuse. So for the right angle triangle ABC, the circumcenter S is going to be the midpoint of AC. That's it. So we need to now focus on finding out the length AC. Once you get length AC, you can say that circumcenter is a midpoint of AC and the radius of that circumcircle, right? You can draw a circle passing through these 3 vertices A, B, and C. So the radius of this circle is going to be half of the hypotenuse. This can be taken as R, the radius R. AS can be taken as a radius R. All right. So we can neglect these two corresponding ratios now. Only focus on AC square by PR square. So AC square by PR. What is PR? PR is given as 5. 5 squared equals to 441 by 49. So upon simplification, what do you do? Take square root on both the sides. AC by 5 equals to 21 by 7. 21 by 7 is 3 here. So 3 into 5, 15. We can say that AC equals to 15 centimeter. Now you know that circumradius or radius of a circumcenter is half of hypotenuse. Half of hypotenuse, which is AC in our case, right? In this triangle, hypotenuse is AC. So AC by 2. So your final answer would be 15 by 2, which is 7.5 centimeter. So option 4, 7.5 would be the answer.